Okay, so now we're back to solving equations once again. First of all, I want to solve this one equation that's labeled as example number 3. In order to solve equation number 3, you have to use what is called the zero product theorem. Let me tell you what the zero product theorem states. It says whenever you multiply two or more quantities together, and let's say the product is 0, well, the only way that's possible is at least one of the factors has to be 0. So take a look at this example number 3. We have 3x times the quantity x minus 4 times the quantity 5x minus 1. And notice, this is the important part, that this product is equal to 0. Well, the only way, again, that can be possible by the zero product theorem is that either 3x has to equal 0, or x minus 4 has to equal 0, or the expression 5x minus 1 equals 0. So one of these three has to be 0 in order for this product to be 0. In fact, stated another way, if any one of these three factors is 0, then the entire product will be 0. So I solved this one by dividing. I solved the first one by, by dividing by 3. When I divide both sides by 3, I get x equals 0. The second one, in order to solve the second equation, all I do is add 4 to both sides, or in other words, move the 4 to the other side, and I get x equals 4. Now the last equation to solve this simple linear equation is I move the 1 over to the other side. I add 1 to both sides. That gives me 5x equals 1. Then I divide both sides by 5, and I get that x is equal to 1/5. So this original equation up here, 3x times x minus 4 times 5x minus 1 equals 0, has three solutions. The solutions are x equals either 0, 4, or 1/5. If you were to take any one of these three numbers, plug it back into the original equation, you will get 0. You would get this expression on the left to equal 0. So that's how you use the zero product theorem. So now moving on to a different type of equation, these are what we call quadratic equations. Now the quadratic equations, let's see what the definition says. A quadratic equation is an equation which can be written in the, I'm going to highlight that, standard form, ax squared plus bx plus c equals 0. Here, a, b, and c are numbers, with a can't equal 0. So, as it says right in here, note that the left-hand side of this equation right here is a polynomial. Well, is it a monomial, binomial, or trinomial? That's going to depend on the numbers a, b, and c. First of all, it's a monomial if b is 0 and c is 0. Then I would just have the expression ax squared equals 0. So the left-hand side would just be a monomial. It's going to be a binomial if either b or c is 0, but not both. If this one is 0, then I only have two terms, ax squared plus c equals 0. If c is 0, then I have ax squared plus bx equals 0. Still, I get a binomial. If none of the numbers a, b, or c are 0, then I have a trinomial. And like it says right here, the requirement that a not equal 0, that implies that the polynomial is of degree 2. So what you have to do, the way you solve a quadratic equation, we'll get to that here in a minute, but the standard form here says that you have to make one side 0. You put everything to the other side of the equation. If the biggest power is 2, then you have a quadratic equation. So here are some examples of some quadratic equations. On this first one here, notice how the right-hand side is 0, and I got this trinomial, x squared plus 9x plus 20 equals 0. Example number 2 is also a trinomial. Notice I got x squared minus 4x plus 5 equals 0. Both of these, in fact, the next one as well, these first three right here, these three right here are already in standard form. How do I know they're in standard form? Because the right-hand side is 0. Now, example number 4 and 5, these are both quadratic equations, but you can't really tell what What you really have to do to show that there are quadratic equations, you have to put these two equations in this standard form up here. So in other words, that's going to mean move the x, subtract x squared from both sides, subtract 2x from both sides, or just move them to the other side. And you will see that this equation can be written just like one of these first two up here. Now the last one, what you have to do first, you have to FOIL or use the special product of binomials formula, multiply that out, and then you take the 10 and subtract it from both sides. And again, you can put it into like one of these or this standard form up here. Now here are three examples over here. Here are three examples that are not quadratic equations. What's wrong with the first one? Well, first one, the degree is wrong. That's a degree 3. It should be degree 2. Now, what's wrong with the second one? Again, it's not of degree 3. I'm sorry, it's not of degree 2. It's a linear. This is a linear equation right here. This one's linear. And then finally, the last one, you see that x squared, and you're thinking, oh, that's quadratic. But you know what happens if you try to subtract x squared from both sides? What's going to happen is that this x squared and this x squared are going to cancel out, and you're going to be left with a linear equation, not a quadratic. Okay, so you have to be able to identify these quadratics, and we'll show how to solve these on the next video.